The topic for this module is water, and I thought it would be useful to take a look at what water does for us, especially in sanitation, and also some of the requirements that we have for the water that we use for cleaning, rinsing, and sanitizing. We can say that water is the major agent that we use for cleaning. In other words, we rely on water to do many different steps for us. And the first step in any cleaning operation is really rinsing. In that case, the water basically serves to loosen up any soil or contaminants that are on the surface for cleaning and then wash them away. Once we have a clean surface, or at least one that's free of this soil, then we can begin washing it using a detergent or a soap. And so this process will do, again, a little bit more for us in terms of getting it clean and actually prepare the surface for the next step, which is sanitizing. And we rely on water, again, to not only rinse the soil away, then to clean up the surface and get it ready for the sanitizer, which is often dissolved in the water. And so water basically is used at every point in this. Quality of the water that we use is, of course, very important, and it has several qualities that are of concern to us. And in this case, what we're seeing this list are problems with the water. In other words, water that isn't quite up to snuff. So the first problem is an obvious one, and that's perhaps odor. So if your water smells, and quite often there's going to be some really nasty smells in water, then that could transfer into the wine and give us some problems. Water is often treated by municipalities with chlorine, and while this serves an important function in that we don't get sick from drinking it, it also has some problems in the winery. And so this is also an area of concern. Hardness refers to dissolved minerals in the water, and basically these dissolved minerals can really screw up the way that sanitizers work, also especially detergents work. So knowing the hardness of your water and how to treat it is actually pretty important. Kind of related to that is the pH. Again, it has a lot of effect on the way that detergents work, and also a lot of sanitizers work at very specific pHs, so we have to be aware of that. The last two things, particulates and microorganisms, really kind of relate to just the way it looks, or even how healthy it is for us. So of course, if you have particulates in your water, that can give you problems in rinsing, in that, if you're trying to rinse off soil, I should say, and what you're rinsing it with has soil in it, then you may not be very effective. Likewise, if you're trying to sanitize something and your rinse water has microorganisms or pathogens that can be harmful to you, then you're not accomplishing much. So all of these qualities then become very important, and we'll take a look at each one of them kind of separately for what maybe the major problem with each one is. And we'll start with odor, and of course probably one that we're most familiar with would be reduced sulfur compounds. And reduced sulfur basically means hydrogen sulfide or rotten egg. So I think we've all been around water that smelled like rotten eggs before, and it's really not a pleasant smell. So it is offensive to work with, and there's sometimes nothing worse than spraying down a tank or something like that, and when you're done, what it smells like is something that's not clean. And so that can be a problem. And then, of course, if you have incidental contact, and or if you sometimes have to use water for dilution in wine, that reduced sulfur can transfer into the wine and perhaps give it an off flavor as well. So in that case, it's not always ideal either. And odor, maybe not necessarily reduced sulfur, but other smells can indicate that there are other problems, whether it be bacterial growth or stagnancy or something like that in the water, that again will indicate a situation that's probably not the best to be working with in wine. Of course, sometimes water's treated when we get it, and especially if we, well, probably always, if we're on a city or a municipal water supply, the water's been treated with chlorine, and we know from earlier class in fundamentals that chlorine in fact gives us a big problem in the winery. And of course that is that it leads to TCA formation, or trichloroanisole, which is that odor that smells somewhat mushroomy or like wet cardboard, and of course it's most associated with cork taint. However, if you have chlorine in the water, or at least chlorine in the winery, it can react with any wood in the presence of mold and also form that within the winery, which is maybe even more severe, because instead of it just being a single bottle, it now becomes the whole, basically all the wine in the winery. Although I will have to say that I have heard some reports that the chlorine in the water is not in sufficient enough quantity to give you a problem with TCA formation. But on the other hand, why take a chance with it? And of course, getting chlorine into the wine itself, so again, rinse water that gets in there, is left in a tank or in a line and combines with the wine, can be very problematic in terms of the aromatics of the wine. So the best thing is to not have chlorine in the water. And of course, filtration systems, or kind of at the far end of the spectrum, a reverse osmosis system, can be used that will strip the chlorine out of the water and make it basically neutral again, which is of course the ideal. Hardness of the water is a term that's used to indicate the high presence of calcium, magnesium, especially those two ions, but also some other metals. And these are ones that occur naturally in water as it passes through basically the rock formations underground. So you'll find areas of the country where the water is naturally harder or softer than in other areas. And the problem with water hardness is that it actually interferes with the actions of soaps and detergents. So in other words, if you have hard water, it may be that in order to be effective, a detergent or soap has to be used at a higher concentration. And so for that reason, it's important to know how hard the water is and then make adjustments accordingly. There are water softeners available, and I think a lot of us may be familiar with these. They're found in a lot of homes, and they basically use an ion exchange column. They run the water through that and basically switch out the calcium or magnesium or whatever other ions are giving you the problems with sodium salt, which is basically table salt or something very similar. This works. However, it can also lend some problems in that now you have water that has a high sodium content, and it can in fact also affect the wine quality. So for that reason, water softeners are not always the best approach unless it's the only approach you have. Distilled water, so again a reverse osmosis or a little distillation unit may be a better answer if in fact it's very hard, or you're having a hard time kind of correcting for it. If you have other metals kind of related to this, especially iron and copper, present in the water, and again you have contact between the water and the wine itself, you can get a haze form, often referred to in the classic literature of winemaking as an iron cast or a copper cast. And these are kind of classic hazes that used to be found before stainless steel was used in plastic. And in fact, you could have some pretty nasty hazes because it would, brass fittings were used, and brass contains copper. Raw iron would be used, or steel, and not stainless steel, but just regular steel. And this would leach into the wine eventually and create these casts or these hazes, and they required treatment. They're not very common anymore because of the materials that we're using now. Another part or quality of water that gives us some concern would be the pH. And normally, in fact ideally, water would be at a pH of 7. However, that's usually not the case because water is almost never pure water when we get it. In fact, it probably is never pure water. And so the pH then ranges from anywhere from a low of 5, so that's fairly acidic, up to 8.5 or a little bit alkaline. And in this range, it's fine. There's no problem. However, if you get above that range, the water becomes very alkaline. And if you're using any sort of an acid sanitizer, such as peroxyacetic acid, then it can be rendered basically ineffective. In other words, the pH is too high and it neutralizes the acid which is required for that sanitizer. On the other hand, if your water is very low, so below pH of 5, then that pH may render alkaline sanitizers ineffective. And a common one here is a proprietary formula called B-Bright, which is basically just an alkaline cleaner with hydrogen peroxide in it. And maybe a more common name for this that you might be more familiar with is OxiClean. So any of the OxiClean type products would be rendered at least less effective, if not totally ineffective, at low pH.